Good evening, everyone. Welcome to tonight's episode of Science to Sleep By. Tonight, as you settle in and let your mind drift into a calm and gentle state, we'll take a journey across time itself back to the very beginning. We'll explore one of humanity's oldest and deepest questions. How did the universe start? Imagine the stars above you, the quiet hum of the cosmos surrounding you, and let curiosity guide you into a space where science meets wonder. This is not just a lecture, it's a story meant to soothe you, to spark imagination, and to carry you gently toward rest. From the earliest days of human existence, long before science took shape as a discipline, men and women looked up at the night sky and wondered where it all came from. The vast canopy of stars, the silvery glow of the moon, the fiery path of the sun, all of these sights inspired a profound curiosity that has never left us. Around campfires and within temples, in caves and under the open heavens, people across every culture and time ask the same haunting question: how did it all begin? This question, the mystery of origins, sits at the heart of human consciousness. It is not just a scientific problem. It is a story we have been telling ourselves since the beginning of language. Ancient civilizations spun myths to explain the stars. Some believed the world was born from a cosmic egg. Others imagined a great ocean out of which the land and heavens rose. Some told of gods who spoke the world into existence, while others envisioned an eternal cycle of death and rebirth, with universes rising and collapsing like breaths of a great cosmic being. For early humans, these stories were not mere entertainment. They were attempts to make sense of existence, to explain the mystery of why there is something rather than nothing. When you gaze at the stars, stretching endlessly across the velvet of the night, it is difficult not to ask, where did all of this come from? Why is there light, matter, and life? And perhaps more deeply, why are we here to wonder about it at all? Over thousands of years, as societies grew more complex, so too did the questions. The Greeks asked whether the cosmos had always existed or whether it had a beginning. Philosophers like Aristotle argued that the universe was eternal, that it had no first moment, but simply always was. Yet others, such as the Stoics, imagined fiery cycles of destruction and renewal, in which the universe was reborn again and again from its ashes. In India, ancient Vedic thinkers described cosmic cycles lasting billions of years, ages upon ages of creation and dissolution, long before Western science would even consider such enormous scales of time. Even in the United States today, as people drift into bed and let their minds wander before sleep, many still find themselves asking the same timeless question. Our telescopes are bigger, our mathematics more refined, but the wonder remains unchanged. The mystery of origins speaks not only to scientists, but to everyone who has ever stared at the Milky Way and felt small yet connected to something vast beyond measure. When we speak of beginnings, we are often also speaking about ourselves. To ask how the universe started is to ask where we come from, what our place might be in the grand unfolding of time. It is a question of roots, but it is also a question of meaning. Each person, lying awake beneath the hum of modern life, has at some point wondered, what came before me, and what came before everything? As science matured in the past few centuries, new tools allowed us to seek answers in ways our ancestors could not have imagined. Telescopes revealed galaxies far beyond our own. Mathematics allowed us to model the expansion of space. Physics uncovered hidden laws that govern matter and energy. And yet, with all these advancements, the question of beginnings has never fully been solved. Instead, it grows deeper. For each answer we discover, new mysteries unfold, drawing us further into the unknown. Consider the way we now understand light from distant stars. When you look up into the night sky from anywhere in America, whether it's the quiet deserts of Arizona or the wide fields of the Midwest, you are not seeing stars as they are now, you are seeing them as they were. Light travels across space at a fixed speed, so a star 100 light-years away is seen as it existed a century ago. The farther away the star, the farther back in time we are looking. And so, when astronomers peer through their telescopes, they are not only studying distant galaxies, they are watching ancient history unfold. In a sense, the night sky is a time machine, carrying us back to the beginnings of everything. This realization that the universe has a history written in light has changed our understanding of origins forever. It means we are not cut off from the past. The story of beginnings is not locked away beyond reach. Instead, it streams constantly into our eyes, into our telescopes, into our imaginations, offering us fragments of the great cosmic tale. Every photon of starlight that reaches us tonight carries a whisper of the universe's early moments. To fall asleep beneath the stars is to rest under a blanket woven from the threads of time itself. The mystery of origins is also deeply humbling. When scientists discovered that the universe is not static, but expanding, it reshaped the way we think about beginnings. An expanding universe suggests that, if we trace time backwards, everything we see, the galaxies, the stars, the planets, must have once been closer together. This raises the possibility that the universe itself had a starting point, a moment when all space and matter were compressed into something unimaginably small. That idea would become known as the Big Bang, a phrase that would capture both the drama and the simplicity of our beginnings. Yet, even with such scientific theories, the question remains as mysterious as ever. If there was a beginning, what came before it? If there was nothing, how could something arise? And if there has always been something, how can we make sense of eternity? These questions are not just for scientists. They are questions anyone can ponder in the quiet of the night, when distractions fade, and the mind turns toward the infinite. In the United States, where science and faith often live side by side, the mystery of origins resonates across different ways of thinking. For some, the story of the universe's beginning is inseparable from spiritual belief. For others, it is purely a scientific puzzle, to be solved with equations and evidence. But no matter the perspective, the question remains the same. How did everything begin? It unites people across belief systems, cultures, and centuries. It is a shared wonder, a common thread woven into the human experience. This mystery also speaks to something deeply human, our desire for stories. We are storytellers by nature, and perhaps the greatest story of all is the one about how everything began. From myths carved into stone to modern documentaries streamed on glowing screens, we continue to retell the tale of origins, shaping it with each new discovery. And though the details change, the yearning behind the story does not. We want to know where we came from, and in knowing, we hope to glimpse where we are going. So, as you listen tonight, let your imagination rest on this great mystery. Picture yourself standing on a quiet hilltop beneath the night sky. Feel the cool air, hear the silence of the stars, and let the question echo softly in your mind. How did the universe start? You do not need to chase the answer. You do not need to solve the puzzle. Instead, allow yourself to rest in the wonder of the question itself. Sometimes, it is not the answer that soothes us, but the timeless act of wondering. When we speak about the beginning of the universe in modern science, the story most often told is that of the Big Bang. Though the name suggests an explosion, a fiery detonation echoing across the void, the reality is far subtler, more delicate, and in many ways more astonishing than a simple blast. The Big Bang is not the story of matter exploding into empty space, but rather of space itself expanding, of time itself beginning. It is a tale of everything: the stars, the galaxies, the atoms in your body emerging from an initial state so small and dense it defies ordinary comprehension. The idea of the Big Bang was not immediately embraced. In fact, for much of human history, it would have seemed absurd to suggest that the universe had a beginning at all. Many believed the cosmos was eternal and unchanging, existing as it always had and always would. Even great scientists of the early 20th century clung to the idea of a static universe, one that simply persisted in a steady state. The notion of a beginning, of a first moment of time, was unsettling, strange, and almost unthinkable. The seeds of the Big Bang theory were planted in the 1920s, when the astronomer Edwin Hubble made a remarkable discovery. Using a telescope in California, Hubble observed that distant galaxies were not stationary. They were moving away from us. Not only that, but the farther away a galaxy was, the faster it seemed to recede. This pattern could only mean one thing: the universe itself was expanding. Space was stretching, carrying galaxies apart like raisins embedded in a rising loaf of bread. This realization changed everything. If the universe was expanding now, then long ago it must have been smaller, denser, and hotter. If you were to rewind the cosmic film, tracing the motion of galaxies back through time, all would converge toward a single, compact state. That state, unimaginably dense and unimaginably hot, would mark the beginning of the universe as we know it. The phrase Big Bang was first used not by a supporter of the theory, but by one of its critics. In 1949, British astronomer Fred Hoyle, who favored the idea of a steady, eternal universe, referred to the concept dismissively as this Big Bang idea. Yet the term stuck, and over time, came to define the most widely accepted model of cosmic origins. To imagine the Big Bang, set aside the picture of an explosion in space. Instead, think of space itself unfolding. At the beginning, the universe was smaller than a subatomic particle, a singularity where the laws of physics as we know them ceased to apply. Then, in less than a fraction of a second, space began to expand. Time began to flow. Energy condensed into matter. In that first instant, the conditions were so extreme that no words truly capture their intensity. Temperatures soared beyond anything found in the core of stars. Densities exceeded anything we can imagine. And yet, within this chaos, the seeds of everything familiar, the atoms that would form you and me, were already present, waiting to unfold. In the first few minutes after the Big Bang, the universe was a roiling sea of particles, protons, neutrons, electrons, photons. It was too hot and too dense for atoms to exist. But as the universe expanded, it cooled. Slowly, hydrogen and helium nuclei formed, the simplest building blocks of matter. These would become the raw ingredients from which stars would later ignite. The cosmos, in its infancy, was dark, filled with a dense fog of charged particles. Light itself could not travel freely. The universe was alive but hidden. For nearly 400,000 years, this fog persisted. Then, as expansion continued, the universe cooled enough for electrons to settle into orbits around nuclei, forming the first true atoms. With that, the fog lifted. Light was freed, and for the first time the cosmos became transparent. This ancient light still exists today. Known as the cosmic microwave background, it is the faint afterglow of the Big Bang, bathing the universe in a soft radiation detectable by sensitive instruments. When scientists look at this light, they are peering back nearly 14 billion years, catching a glimpse of the universe as a newborn. The cosmic microwave background is one of the strongest pieces of evidence supporting the Big Bang. Discovered accidentally in 1965 by American scientists Arno Penzias and Robert Wilson, it was first noticed as a persistent hiss in their radio antenna. At first, they thought it was interference, perhaps caused by nearby equipment or even pigeons nesting in the device. But as they studied the signal more carefully, they realized it was something far deeper, a relic from the dawn of time. That faint static was the echo of creation, still resonating across the universe billions of years later. The Big Bang theory also explains why the universe is filled with hydrogen and helium, and only small traces of heavier elements. In those first few minutes, only the simplest elements could form. The heavier ones like carbon, oxygen, and iron were forged much later in the hearts of stars and released into space when those stars died. In a very real sense, the Big Bang gave us the raw material, while stars acted as cosmic forges, shaping the elements of life. The atoms in your body are ancient, stretching back not only to the stars, but to the very first seconds of the universe's birth. In the United States, the story of the Big Bang has become a familiar part of science education, told in classrooms, museums, and documentaries. But despite its familiarity, it retains a sense of wonder that resonates far beyond academia. It is a story that invites us to stretch our imaginations to their very limits. How could everything, every planet, every galaxy, every heartbeat trace its origin to a single moment? How could time itself have a beginning? These are questions that can make us feel very small, and yet, at the same time, profoundly connected to the cosmos. Even today, the Big Bang remains a subject of refinement and exploration. Astronomers continue to measure the cosmic microwave background with increasing precision, mapping its faint ripples, which reveal clues about the earliest structures of the universe. Satellites such as COBE, WMUP, and Planck have given us detailed portraits of this ancient light, showing us that the universe was not perfectly smooth in its infancy, but carried tiny fluctuations. These small variations would eventually grow under the pull of gravity to galaxies, stars, and planets. Without those tiny imperfections, there would be no us. The beauty of the Big Bang story is that it combines both simplicity and mystery. On the one hand, it provides a framework that explains so much: the expansion of galaxies, the composition of matter, the glow of ancient light. On the other hand, it leaves us with profound questions. What caused the Big Bang? What existed before it? Was there truly a before? Or did time itself come into being at that moment? These questions push the boundaries of physics and philosophy alike. The Big Bang is not the final answer, but rather the beginning of a deeper journey. It tells us that the universe has a history, that it is dynamic, evolving, and filled with change. It places us within that grand history, reminding us that everything we are began in that first, fiery instant. And as you rest tonight, drifting slowly into sleep, you might imagine yourself floating back through time, carried on waves of starlight, until you reach that first moment when everything began to unfold, when silence and darkness gave way to expansion and light, and the story of the universe was set into motion. The Big Bang offers us a remarkable framework for understanding how the universe unfolded from its earliest observable moment. Yet it leaves us standing at the very edge of knowledge, staring into a question that feels even more mysterious. What came before? Was there a before at all? Did something exist prior to that moment? Or did the Big Bang mark the true beginning of time, of a space, of everything? This question pushes us into the realm where science, philosophy, and imagination converge, and where the mind drifts between awe and bewilderment. To grasp this mystery, it helps to remember that the Big Bang is not an explosion in space, but the expansion of space itself. Time and space, as we understand them, emerged from that initial moment. This means that asking what came before the Big Bang may not even be a meaningful question in the traditional sense, because before assumes there was time. If time itself began with the Big Bang, then the concept of before could be an illusion, a frame of reference that doesn't apply at that scale. It's like asking what lies north of the North Pole. The question itself may not fit the nature of reality, and yet, human curiosity cannot help but wonder. Our minds seek patterns and causes. If the universe has a beginning, we want to know what triggered it. If time began with the Big Bang, then what is the origin of time itself? Was there something beyond, hidden behind the veil of that first instant, inaccessible to our instruments, but not beyond imagination? Different ideas have been proposed by scientists who are willing to peer into this mystery. One possibility is that the universe emerged from what physicists call a quantum fluctuation. In the strange world of quantum mechanics, particles can appear and disappear in the vacuum of space, borrowing energy for fleeting moments before vanishing again. Some theorists suggest that the universe itself might have arisen in a similar way from the froth of quantum possibilities, a tiny bubble of energy swelling into the vast cosmos we see today. If this is true, then the universe may have no cause. In the traditional sense, it may have simply arisen from the fabric of quantum reality, without a trigger, without a before. This idea can feel unsettling, because it challenges our instinctive belief that everything must have a cause. And yet, in the silence of the night, when you allow your mind to drift toward the infinite, there is also something strangely soothing in the thought that the universe may simply be arising naturally, like a wave on an endless sea. Another possibility is that the Big Bang was not the beginning, but simply a transition. Some scientists propose that our universe might be one of many, part of an eternal cycle of births and deaths. In these models, the cosmos undergoes expansions and contractions, perhaps collapsing into itself only to rebound in another Big Bang, over and over across infinite time. In this picture, what we call the Big Bang may not be the first beginning, but just the latest chapter in an ongoing story that has no true start and no true end. There is also the idea of the multiverse, a concept that has captured both scientific and popular imagination. According to this view, our universe may be only one bubble among countless others, each with its own laws of physics, its own dimensions, perhaps even its own versions of time and space. The Big Bang, in this context, would not mark the beginning of everything, but only the beginning of our particular universe. Others may have begun before, or may be beginning even now, beyond the limits of what we can observe. The multiverse is not something we can prove or disprove with our current tools, but it expands the imagination into a vast landscape of possibility, even in the United States, where scientific explanations often meet cultural and spiritual interpretations. The question of what came before the Big Bang resonates deeply. For some, the mystery points toward the idea of creation, the possibility that a divine intelligence set the universe into motion. For others, it is a puzzle of physics, to be approached with mathematics and observation. Yet both perspectives share the same wonder, an acknowledgement that the beginning of everything lies beyond easy comprehension. What is striking about this mystery is how it blends scientific curiosity with a sense of poetry. When you imagine the moment before time, you are not just engaging in physics, you are stepping into a realm that feels almost dreamlike. The idea of nothingness, absolute emptiness without space, without time, without matter, is difficult to picture. Our minds are wired to think in terms of something. Even when we try to imagine nothing, we often picture a dark void, but that, too, is something. True nothingness is beyond imagination, and yet it may be the backdrop against which the universe emerged. On the other hand, perhaps there was never nothing at all. Perhaps the universe has always existed in some form, eternally shifting, changing, transforming. In that case, the Big Bang was not a beginning, but a moment of transformation, a reorganization of energy into a new form of existence. In this view, the cosmos may be eternal, with no first moment, no final ending, only an infinite dance of change. When you let these ideas settle into your mind as you prepare for rest, they can feel like gentle waves, carrying you into a sea of possibility. To ask what came before the Big Bang is to stretch your imagination beyond its normal boundaries, into a space where words falter and concepts dissolve. It is a question that humbles us, reminding us that human knowledge, for all its power, still brushes only the surface of the infinite. And yet, there is comfort in that humility. To lie beneath the stars and wonder what came before is to share in a tradition as old as humanity itself. Our ancestors gazed into the night sky with the same curiosity, though they framed their answers in myth and story rather than mathematics and physics. In some ways, we are still telling stories, though now, they are written with equations and telescopes rather than firelight and legend. But the heart of the question remains unchanged. The mystery of what existed before the Big Bang is not one that demands an immediate answer. It is not a riddle to be solved tonight, or perhaps ever. Instead, it is an invitation to wonder, to allow the mind to stretch into the unknown. Like a lullaby sung by the cosmos itself, it encourages us to drift gently into sleep, knowing that some questions are larger than any one answer, and that the act of wondering is itself a kind of peace. To explore the birth of the universe, we must enter a realm that feels both mysterious and counterintuitive, the world of the quantum. Quantum physics describes reality on the smallest imaginable scales, smaller than atoms, smaller than protons and neutrons, down to the level where particles behave more like waves of probability than solid objects. It is a place where certainty dissolves into chance, where particles flicker into and out of existence, and where the ordinary rules of logic no longer hold. It is here, in this shadowy landscape, that many scientists believe the seeds of the universe itself were sown. first glance, the idea of quantum fluctuations may sound abstract, perhaps even unreal. But in truth, they are a fundamental feature of nature. Even in the emptiest vacuum, where we imagine there to be nothing, the laws of quantum mechanics tell us that there is always activity. Tiny particles continually emerge and vanish, borrowing energy from the fabric of space and then returning it almost instantly, so quickly that they leave no trace behind. This restless bubbling of energy is called a quantum fluctuation, and it happens everywhere, all the time. In everyday life, these fluctuations are invisible, drowned out by the larger, steadier forces of the macroscopic world. But in the earliest moments of the universe, when everything was smaller than an atom, quantum fluctuations were not just background noise, they were the defining feature. The randomness of the quantum realm, magnified by cosmic expansion, shaped the structure of everything that followed. In this sense, you and I, the stars above and the galaxies that stretch across billions of light years, may owe our existence to those first flickers of uncertainty. Imagine the scene: the universe in its earliest instant, a hot and dense state, beyond comprehension. Within that moment, fluctuations of energy ripple across the tiny fabric of space. Some regions swell slightly more than others, while some shrink, all due to random quantum effects. As the universe expands, these fluctuations are stretched and magnified, like patterns unfolding across a balloon as it inflates. Eventually, those small variations become the seeds of galaxies, stars, and planets. Without them, the universe would have been too uniform to smooth, with no structures, no clusters, no worlds. Every star that burns in the night sky, every galaxy spiraling in cosmic silence, may be the echo of a quantum ripple that occurred in the universe's first heartbeat. This idea that randomness at the quantum level gave rise to cosmic order challenges our sense of how reality works. We often imagine that the universe should be logical, orderly, deterministic. Yet at its root, it may be built on chance, on fluctuations that have no cause beyond the very uncertainty woven into the laws of physics. For many, this is unsettling, but for others, it is deeply poetic. It suggests that the universe is a blend of chaos and harmony, chance and necessity. It suggests that out of the smallest flickers of possibility, vast galaxies can grow. In the United States, where science often blends with imagination and popular culture, the idea of quantum origins has inspired countless stories. Movies, books, and television shows have borrowed from this strange reality, weaving tales of parallel universes and quantum leaps. While many of these are playful exaggerations, they reflect something real: the fascination with the idea that at the heart of everything lies a deep unpredictability. To imagine that the universe itself may have sprung from such fluctuations is to embrace the notion that reality is far stranger and more creative than we once believed. Physicists have attempted to describe this process with mathematics, constructing models where the universe can emerge from a quantum vacuum. The word vacuum here can be misleading, because it does not mean absolute nothingness. Instead, it is a kind of quantum sea, a state with no matter or radiation, but still pregnant with potential. Within this sea, a fluctuation could generate a small patch of energy. If conditions are right, that patch could expand, creating space and time. In this way, a universe might blossom from what appears to be nothing, carried into being by the laws of quantum mechanics. This does not mean that something comes from nothing in the ordinary sense. Rather, it reveals that what we call nothing is not truly empty. It is alive with potential, with fields and probabilities that can, under the right conditions, give rise to entire realities. This idea has led some scientists, such as Stephen Hawking and Lawrence Krauss, to suggest that the universe could, in principle, create itself spontaneously. No external push, no outside agent, only the natural unfolding of quantum laws. Of course, such ideas remain controversial, and they highlight the limits of our understanding. The mathematics of quantum cosmology is difficult, incomplete, and often speculative. We do not yet know whether these theories fully capture the truth. But what they reveal is a remarkable possibility, that the randomness of the quantum world may be the ultimate artist, painting the canvas of the cosmos with strokes of uncertainty. The role of quantum fluctuations is not just theoretical. Evidence for their influence can be seen in the cosmic microwave background, the faint afterglow of the Big Bang. When scientists map this ancient light, they find tiny variations in its temperature, small ripples that correspond to the early fluctuations of energy in the newborn universe. These ripples, imprinted on the cosmos nearly 14 billion years ago, are the fingerprints of quantum mechanics writ large across the heavens. Each faint blotch in the microwave background is a clue to how quantum chance became cosmic structure. To lie beneath the stars and imagine this is to experience a humbling wonder. Consider that the Milky Way galaxy, with its billions of stars, its clouds of gas and dust, its spiral arms curving gracefully through space, may have begun as a tiny unevenness, a random fluctuation in the universe's earliest moment. Consider that the Earth, the oceans, the forests, the very atoms in your body, may trace their lineage back to quantum ripples too small to see, magnified by cosmic expansion into the architecture of reality. This perspective can change the way we think about existence. Instead of a universe that is rigid, predetermined, and unyielding, we find one that is dynamic, creative, and deeply tied to chance. It is as if the cosmos itself has an improvisational spirit, weaving order out of randomness, beauty out of uncertainty. Some may ask whether this diminishes the significance of our lives, if everything is the product of chance. But another way to see it is as a reminder of our extraordinary connection to the universe. To exist at all in a cosmos born of quantum fluctuation is a miracle of improbability. Every heartbeat, every thought, every dream is a continuation of that first ripple. In this sense, you are not separate from the quantum origins of the universe. You are one of its natural expressions, a conscious echo of its earliest whispers. As your mind drifts into quiet reflection tonight, you may find comfort in this thought. The universe is vast, mysterious, and beyond full comprehension. Yet its origins may rest in something as delicate as a quantum fluctuation, a tiny shimmer in the fabric of nothingness. From that shimmer came galaxies, stars, planets, oceans, and the quiet moment you inhabit now, listening, breathing, resting, and feeling yourself part of an endless, unfolding story. If the Big Bang describes the birth of the universe, then cosmic inflation is the explanation for its first breath, a sudden, rapid expansion that occurred in a fraction of a second after the universe began. Inflation is one of the most astonishing and elegant ideas in modern cosmology, a theory that attempts to explain not just that the universe exists, but why it looks the way it does. It tells the story of how the universe grew from something unimaginably tiny to something vast, smooth, and structured, laying the foundation for all that followed. To picture inflation, imagine the universe as smaller than a single atom, a tiny speck of energy containing all the potential of space and time. Then imagine that speck expanding at a speed far faster than light, not for minutes or hours, but for a fleeting instant so short we can hardly comprehend it. In less than a trillionth of a second, the universe grew exponentially, stretching space itself until it was large enough to contain the galaxies, stars, and planets that would eventually form. This was not an explosion into pre-existing space, it was the creation of space, the unfolding of the cosmic fabric itself. The idea of inflation was first proposed in the early 1980s by physicist Alan Guth, who was searching for a way to resolve puzzling questions about the Big Bang. The classic Big Bang model, while powerful, left several mysteries unanswered. One of these is known as the horizon problem. When we look across the universe, in every direction, we see that it is remarkably uniform. The cosmic microwave background radiation, the afterglow of the Big Bang, has nearly the same temperature everywhere we measure it. But why should this be so? If different regions of the universe were once too far apart to influence each other, how could they all have ended up so evenly balanced, as though they had somehow shared the same conditions? Inflation provides an elegant solution. In its earliest moment, the universe was incredibly small, so small that every part of it could influence every other part, reaching a kind of equilibrium. Then, inflation caused this tiny, balanced patch to expand rapidly, carrying its uniform conditions outward until it became the vast universe we see today. What we perceive as large and separated regions of space were once intimately connected, before inflation stretched them apart. Another mystery solved by inflation is the flatness problem. Observations show that the geometry of the universe is astonishingly flat, not curved like a sphere, not saddle-shaped, but almost perfectly level, as though space itself has been iron smooth. Without inflation, this flatness would be difficult to explain, because even a slight curvature at the beginning would have grown dramatically over billions of years. Inflation, however, stretches space so enormously that any initial curvature would be flattened out, just as the surface of a balloon seems flatter the larger it becomes. This explains why the universe we inhabit today appears so flat and uniform, even across unimaginable distances. Inflation also helps explain why the universe is filled with galaxies and cosmic structures, rather than remaining a featureless void. Those tiny quantum fluctuations we explored earlier, random ripples in the fabric of energy, were amplified by inflation. During that brief but violent expansion, minuscule variations in density were stretched into patterns, creating the seeds of cosmic structure. Over billions of years, gravity pulled matter into these denser regions, forming galaxies, clusters, and eventually stars and planets. Without inflation, the universe might have remained too smooth, lacking the diversity and complexity we now see. The beauty of inflation is that it not only solves problems, but does so in a way that feels almost poetic. It takes the smallest, most delicate fluctuations and magnifies them into the architecture of reality. It transforms chance into pattern, certainty into structure. In the hush of the night, when you let your imagination drift across the stars, you might picture inflation as the universe taking its first deep breath, exhaling into existence the vastness of space we now call home. Evidence for inflation is indirect, but compelling. The tiny ripples seen in the cosmic microwave background match the predictions of inflationary models, showing the fingerprints of those early quantum fluctuations. These faint irregularities are not random, they fit the pattern of an inflationary origin, suggesting that the story of rapid expansion is woven into the very fabric of the cosmos. For scientists in the United States and around the world, inflation has become one of the cornerstones of modern cosmology, a guiding principle in the quest to understand beginnings. Yet it remains a theory, one still tested, refined, and challenged. Different versions of inflation have been proposed, each attempting to describe the precise details of how it unfolded. Some suggest inflation may still be happening in other regions of the multiverse beyond our reach. If that is true, then our universe may be just one bubble in a vast cosmic foam, each bubble born from inflation, each with its own properties and possibilities. The thought of eternal inflation, the idea that inflation may never fully stop, endlessly creating new universes, carries a strange comfort. It suggests that creation is not a single event locked in the past, but an ongoing process, a continual blossoming of reality. In this picture, the Big Bang is not unique, but one of countless beginnings, with universes sprouting like wildflowers across an infinite field. It is an image both humbling and uplifting, reminding us that our cosmos, for all its vastness, may be part of something even greater. For many people, inflation is difficult to imagine because it operates on scales far beyond human experience. To help visualize it, think of a tiny balloon inflated with a sudden burst of air. At first, the balloon is small, its surface wrinkled and uneven. But as it expands, it smooths out, stretching until it appears flat to an observer standing close to it. Now, take that simple image and magnify it by unimaginable factors, replacing air with the expansion of space itself, replacing a balloon with the fabric of the universe. Inflation did not simply stretch space, it created the room in which everything else could exist. When you lie beneath the quiet of the night sky, It can be soothing to reflect on inflation as the hidden breath that allowed the stars to shine. Without it, the galaxies would not exist in their graceful spirals, the planets would not orbit their suns, and the Earth itself might never have formed. Every moment of life, every whisper of wind, every ocean wave is tied to that fleeting instant of expansion nearly 14 billion years ago. There is also a poetic irony in inflation's nature. It was unimaginably fast, over almost as soon as it began, yet its consequences endure forever. A moment shorter than the blink of an eye set the stage for billions of years of cosmic history. The vast sweep of galaxies, the evolution of stars, the rise of life, all trace back to that sliver of time when the universe grew from the size of a quantum particle to something vast enough to contain everything that would ever exist. In the United States, where stargazing is woven into cultural memory from the Native American traditions that map stories onto the constellations, to the space age that put footprints on the moon, the idea of inflation resonates with a familiar theme: growth from small beginnings. Just as a seed grows into a towering tree, just as a dream grows into a journey, so too did the universe grow, almost instantly, into the grand stage upon which all of history would play out. As you rest tonight, you may find peace in this thought, that the stars above, the galaxies stretching across billions of light years, the Earth beneath your feet, and even your own existence, were made possible by a silent expansion in the universe's first fraction of a second. Inflation was the whisper that set creation into motion, the hidden breath that gave space for everything to unfold, the unseen hand smoothing and stretching the cosmos into the vast, shimmering expanse we now call home. Once the rapid growth of inflation subsided and the universe began to cool, it entered a new chapter, one that would eventually lead to the birth of stars, galaxies, and the cosmic structures that fill the night sky today. If inflation was the first breath of the cosmos, then the formation of stars was its first heartbeat, the moment when light and structure began to emerge from darkness. This stage in the universe's history is often called the cosmic dawn, and it marked the transition from a universe of simplicity to one of breathtaking complexity. In the earliest times, the universe was almost entirely uniform, filled mostly with hydrogen and helium, the simplest of all elements. These gases drifted across space like an invisible ocean, spread nearly evenly throughout the cosmos. The universe then was dark, for though light itself had been released when atoms first formed, there were no stars yet to shine, no galaxies to sparkle against the black. Imagine a vast emptiness filled only with faint clouds of gas and the echo of the Big Bang's afterglow, a quiet, endless sea awaiting change. But this uniformity was not perfect. Inflation had magnified tiny fluctuations in density, creating regions slightly denser than others. Over time, gravity began to pull matter toward these denser regions, like invisible hands gathering threads into knots. Slowly, the cosmic fog began to clump. Small overdensities of hydrogen and helium grew heavier, drawing in more and more material. The universe was only a few 100 million years old, but already the seeds of structure were beginning to take shape. As these clouds of gas collapsed under gravity, they began to heat up. In their centers, pressure built as atoms collided again and again, faster and harder. Eventually, in some of these dense knots, the temperature and pressure grew high enough for nuclear fusion to ignite. Hydrogen nuclei fused into helium, releasing energy in the form of light and heat. And with that, the first stars were born. These first stars were unlike the ones we see today. They were massive, hundreds of times larger than our sun, burning hot and bright, living short, violent lives. Their immense size made them unstable, fusing their fuel at an extraordinary pace. They illuminated the darkness, casting the first starlight into a universe that had known only shadow. This moment, the lighting of the first stars, was the beginning of cosmic illumination, the end of what astronomers call the cosmic dark ages. The light of these stars did more than brighten the universe. It began to reionize the hydrogen gas that filled space, stripping electrons from atoms and changing the very state of the cosmos. The stars were sculptors, reshaping their surroundings. with radiation and winds, carving the gas into new patterns, and preparing the way for future generations of stars to form. But the first stars did not live long. Because they were so massive, they burned through their fuel quickly, exploding as supernova within only a few million years. These explosions were among the most powerful events in the early universe, scattering newly forged elements into the surrounding space. Until this point, the universe had contained only hydrogen and helium, but the deaths of these first stars created heavier elements: carbon, oxygen, nitrogen, iron, the building blocks of planets and life. In this sense, the first stars were both creators and destroyers, brief but essential actors in the unfolding cosmic drama. As stars formed and died, gravity continued its patient work, drawing together even larger collections of gas and stars. Over hundreds of millions of years, these clumps merged and grew, forming the first galaxies. Some were small, containing only a few million stars, while others grew into giants, with billions of stars shining in immense spirals or massive elliptical shapes. Galaxies became the great cities of the cosmos, gathering stars, gas, dust, and dark matter into vast structures that stretched across light years. From our vantage point today, when we look through powerful telescopes, we can see light from galaxies formed more than 13 billion years ago, their faint glow reaching us after traveling across nearly the entire age of the universe. These ancient galaxies are windows into the past, allowing us to glimpse the earliest chapters of cosmic history. In the deserts of the American Southwest, at observatories perched on mountains in Hawaii, and with space telescopes orbiting far above Earth, astronomers have captured these primordial lights, revealing galaxies as they appeared only a few 100 million years after the Big Bang. To see them is to look across both distance and time, to witness the universe learning how to build itself. The formation of stars and galaxies was not an isolated event, but a process that unfolded over billions of years. Small galaxies merged to form larger ones, colliding and combining in spectacular cosmic dances. Stars continued to form within these galaxies, generation after generation, each new star enriched with heavier elements created by the deaths of those before it. Over time, planets formed around many of these stars, tiny worlds orbiting their suns, carrying the potential for oceans, atmospheres, and perhaps even life. It is humbling to reflect on how intimately our own existence is tied to this story. The carbon in our bodies, the oxygen we breathe, the calcium in our bones, all were forged in the hearts of ancient stars that lived and died billions of years ago. The galaxies that first emerged from the primordial fog were the crucibles in which the elements of life were created. When you breathe in, when your heart beats, you are participating in a story that began with the birth and death of the first stars. The sheer scale of this story can feel overwhelming, yet there is comfort in its grandeur. To lie under the American night sky, whether in the quiet stillness of the Great Plains or beneath the forests of the Pacific Northwest, is to connect with a history that stretches back to the cosmic dawn. Every star you see is part of a galaxy, and every galaxy traces its lineage back to those first luminous giants that ended the darkness. Astronomers sometimes describe the universe as a kind of living organism, growing, evolving, and changing over time. If this is true, then the formation of the first stars and galaxies was the universe's first great act of creation, a moment when simplicity blossomed into complexity. Hydrogen, the lightest of elements, transformed into heavy metals. Dark voids gave way to glowing structures. Silence became filled with the hum of starlight. Even today, galaxies continue to form and evolve. Stars are born in vast clouds of dust and gas, sometimes called stellar nurseries, glowing with the soft light of new creation. Other stars reach the ends of their lives, exploding in brilliant displays, scattering their enriched elements into space, to be recycled into future stars and planets. The cycle of birth and death, of creation and transformation, continues as it has since the first stars ignited. When you reflect on this process in the quiet of night, it can feel like listening to a cosmic symphony, one that has played for billions of years. Each star is a note, each galaxy a chord, and together they create a harmony that stretches across the universe. You are part of that harmony, a being made of stardust, looking back across time to witness the universe's first lights. The galaxies that began as small ripples in the aftermath of inflation have become the grand stage upon which the story of existence unfolds, and their luminous stars still shine as reminders of how darkness gave way to light, and how the quiet cosmos blossomed into brilliance, while the Big Bang remains the most widely accepted explanation for how the universe began. It is not the only idea that scientists have explored. The story of cosmic origins is far from complete, and like all good mysteries, it invites many possible answers. Across decades of study, alternative theories have risen and fallen, each offering its own perspective on how everything we see around us might have come into being. Some of these ideas challenge the Big Bang directly, while others try to extend or refine it, addressing questions that the Big Bang alone cannot fully explain. To listen to these possibilities is like hearing different versions of a great song, each variation carrying its own rhythm, its own melody, yet all trying to capture the same grand theme, the beginning of everything. One of the earliest alternatives to the Big Bang was the steady-state theory. Proposed in the mid-20th century, this theory suggested that the universe had no beginning at all. Instead of exploding into existence at a single moment in time, the universe, according to steady-state cosmology, had always existed and would always exist. As galaxies moved apart from each other, new matter would constantly be created, filling in the gaps and maintaining the universe's density. In this view, the universe had no dawn, no singular moment of birth, but was eternal and unchanging in its overall appearance. For a time, the steady-state theory was taken seriously, even embraced by some prominent scientists. It carried a certain philosophical appeal, offering a vision of the cosmos without the need for a dramatic beginning or an ultimate end. But the discovery of the cosmic microwave background radiation in 1965 dealt a heavy blow to this idea. The faint afterglow of the Big Bang provided strong evidence that the universe did indeed have a hot, dense beginning. The steady-state model could not account for this radiation, and so it slowly faded into history, though it remains an important reminder of how science grows by testing, refining, and sometimes discarding its ideas. Another compelling concept is the cyclic universe. In this vision, the universe has not just one beginning but many, expanding and contracting in an eternal rhythm. Imagine the cosmos as a great cosmic heartbeat. A Big Bang brings it into existence. It expands for billions of years, then one day gravity slows and reverses the expansion, leading to a collapse called the Big Crunch. From the collapse, a new Big Bang is born, and the cycle begins again. This idea appeals to the imagination, offering a universe without a true origin or end, but rather an endless cycle of rebirths. Though the cyclic universe is beautiful in its symmetry, it too faces challenges. Observations today show that not only is the universe expanding, but the rate of that expansion is accelerating, driven by a mysterious force called dark energy. If this acceleration continues, the universe may never collapse back into a crunch, making the cycle impossible. Still, some scientists explore ways in which dark energy itself might change over time, possibly allowing the universe to reverse course. In the quiet of night, it is intriguing to imagine that everything we know is just one verse in an infinite cosmic song, repeated across eternity. Closely related to these cyclic models is the idea of a bouncing universe. In this theory, instead of starting from nothing, the Big Bang was actually the rebound of a previous universe that had collapsed in on itself. Think of a ball hitting the ground and bouncing back upward. In this metaphor, our universe is one of many bounces, with no true beginning and no final end. The bounce theory offers a way to avoid the troubling question of what came before the Big Bang, by suggesting that time stretches infinitely in both directions. Yet another alternative that has gained attention is the multiverse hypothesis. In this vision, our universe is not the only one. Instead, it is one bubble among countless others, each with its own laws of physics, its own constants, perhaps even its own dimensions of time and space. The multiverse arises naturally in some interpretations of cosmic inflation, suggesting that inflation may not have happened everywhere at once but in patches, creating countless expanding bubbles. Some of these bubbles might die out quickly, while others like ours expand and develop into full universes with stars, galaxies, and perhaps even life. The multiverse is one of the most daring ideas in modern cosmology, and it raises both wonder and frustration. On one hand, it could explain why the laws of physics in our universe seem so finely tuned to allow life. If there are countless universes, each with different conditions, it would not be surprising that we happen to live in one that allows us to exist. On the other hand, the multiverse is notoriously difficult to test or observe. By definition, other universes would be beyond our reach, separated from us by space, time, or entirely different dimensions. This makes the multiverse a deeply fascinating but scientifically elusive idea. Other alternative theories arise from the strange realm of quantum physics. Some scientists suggest that the universe began not as a singularity, but as a quantum fluctuation, a momentary blip of energy in a quantum vacuum. In this view, the Big Bang was not the beginning of everything, but the emergence of order from a deeper quantum reality. Such ideas challenge our everyday understanding of cause and effect. For, in the quantum world, uncertainty and probability rule. The notion that the universe itself might have sprung from a quantum fluctuation stretches the imagination, but it is consistent with the laws of physics as we understand them. There are even proposals inspired by string theory, a framework that suggests the fundamental building blocks of reality are not particles, but tiny vibrating strings. In some versions of string theory, our universe is just one three-dimensional slice, or brane, floating in a higher dimensional space. Collisions between these branes could give rise to events like the Big Bang, suggesting that our universe's birth was the result of a cosmic collision in a hidden, higher dimensional arena. What is striking about all these alternative theories is not that they are in competition with one another, but that they reflect the human drive to imagine possibilities. The Big Bang explains much, but it does not answer every question. What caused the Big Bang? What set the laws of physics in motion? Why does the universe exist at all, instead of nothing? Each alternative theory is a way of reaching toward these mysteries, of trying to illuminate the shadows that remain at the edges of our knowledge. For those listening in the stillness of the night, there is something profoundly calming about this uncertainty. The fact that even the greatest minds cannot say with certainty how the universe began reminds us that mystery is not something to fear, but something to embrace. Science is a journey, not a destination, and every question we cannot yet answer is an invitation to wonder, to look up at the stars and know that the universe might be part of an endless cycle, or one bubble in a vast multiverse, or the product of a quantum fluctuation, is to let your imagination roam freely across the cosmic landscape. In a way, alternative theories are like dreams, shimmering possibilities that expand our sense of what could be true. Just as the first stars lit the darkness, these ideas illuminate the unknown, guiding us toward deeper questions and richer stories. Whether the universe is eternal, cyclical, bouncing, or just one among many, each vision offers a perspective that deepens our appreciation of the cosmos. And though we may not have definitive answers, we can find peace in the knowledge that the act of wondering itself connects us to the very essence of being human, to the ancient curiosity that has driven us to look up at the night sky. For as long as we have existed, even after all the theories, all the discoveries, and all the careful observations of the cosmos, one truth stands unshaken. The origin of the universe remains an ongoing mystery. Humanity has made extraordinary progress in understanding the workings of the natural world, from the laws of gravity to the behavior of subatomic particles, from the birth of stars to the slow dance of galaxies across billions of years. Yet, when it comes to the ultimate question, why is there something rather than nothing? How did it all truly begin? We find ourselves standing at the edge of knowledge, gazing into a horizon of uncertainty. The Big Bang Theory provides a powerful framework, one that matches observations and explains the expansion of the universe, the abundance of light elements, and the cosmic microwave background radiation. But even this well-established idea cannot reach back infinitely. It gives us a picture of what happened after the first fraction of a second, yet it does not tell us what triggered that moment or what, if anything, came before it. The singularity at the start of time remains a veil, beyond which our current physics cannot see. Like a curtain drawn across a stage, it blocks us from witnessing the opening act of the cosmic drama. Science thrives on uncovering mysteries, yet there is always the possibility that some questions may never be fully answered. The nature of time itself poses one such challenge. If time began with the Big Bang, then asking what came before may be like asking what is north of the North Pole, a question that does not quite make sense within the framework we use. But the human mind is not easily satisfied with limits. We push, we probe, we imagine, driven by an innate desire to understand not just the mechanics of the universe, but the profound meaning of existence. What makes the ongoing mystery so captivating is that it holds both scientific and philosophical weight. For scientists, it is a puzzle to be solved, a frontier to be crossed. For philosophers, it is a doorway to questions of purpose, reality, and the possibility of meaning behind existence itself. For those listening as night falls and thoughts grow quiet, it is also a source of wonder, an invitation to let the imagination drift where knowledge cannot yet go. The mystery is not frustrating, it is calming, expansive, and deeply human. The unknown also reminds us of humility. Throughout history, humanity has often believed it was close to final answers. There was a time when the Earth was thought to be the center of the universe, another time when the stars were believed to be fixed upon crystal spheres, and still another when the Milky Way was thought to be the whole of existence. Each generation pushed beyond the boundaries of its understanding, only to discover that the cosmos was larger, stranger, and more astonishing than they had imagined. It is likely that our generation, too, is standing on the edge of an even greater revelation, one that future humans will look back on as just the beginning of cosmic understanding. The ongoing mystery is not just about where the universe came from, but also about where it is going. If the cosmos had a beginning, will it also have an end? Will it expand forever, growing colder and emptier with time until even the last stars flicker out, leaving only darkness? Or will there be cycles, bounces, or rebirths, ensuring that creation is not a singular event, but an eternal rhythm? These questions blend seamlessly with the mystery of beginnings, for origins and destinies are woven together in the same cosmic fabric. In the quiet of reflection, one might also consider the mystery of consciousness itself. The universe began, stars formed, planets coalesced, and eventually life arose. And from life, awareness, consciousness emerged. The fact that we are able to ask these questions, to reflect upon the universe, is itself a mystery layered atop the greater one. How remarkable it is that the universe not only exists, but has given rise to beings capable of contemplating existence. The ongoing mystery, then, is not just external, written in the stars, but also internal, present in the very fabric of the human mind. Even in uncertainty, progress continues. Telescopes peer deeper into space, collecting light that has traveled for billions of years. Particle accelerators recreate conditions close to the birth of the universe, smashing particles together to glimpse the laws that shaped reality. Mathematical models push further into the unknown, offering glimpses of possibilities beyond the limits of observation. Each discovery sharpens the picture, yet each answer seems to unfold into new questions, reminding us that mystery is not an obstacle but a path. There is comfort in this unending search. If the universe were simple, if its origin could be neatly explained and wrapped up like a solved equation, the story might feel smaller, less alive. Instead, the cosmos offers us endless depth, always one layer more to uncover, one horizon further to reach. It is as though the universe itself insists that we remain curious, that we never stop asking, never stop wondering, never stop exploring. For those drifting into rest, this thought can be a balm. The mystery of the universe's beginning is not a burden on the mind, but a wide, open space where imagination can wander freely. To think of the universe as a puzzle without a final solution is to accept that wonder itself is part of the design, that the journey of discovery is as important as the destination. The ongoing mystery gives us permission to dwell in awe, to embrace the unknown as a companion rather than a barrier. Some may turn to spiritual traditions, others to scientific inquiry, and many to both, each path reflecting humanity's longing for connection with something greater than itself. While science seeks mechanisms and philosophy seeks meaning, both share the same starting point: the recognition that existence itself is astonishing. Whether the universe emerged from a quantum fluctuation, cycle of rebirths, or something beyond even our wildest imaginations, the fact that it exists at all is a profound mystery that touches every human life. And so, the story of the universe's beginning is not finished. It may never be finished. It is a tale written in starlight, in equations, in dreams, in the soft curiosity that fills the quiet hours of night. Each person who looks up at the stars participates in this mystery, each question adding a note to the great symphony of wonder. In this way, the ongoing mystery is not a void, but a fullness, not an absence of answers, but an abundance of possibilities, waiting to be explored. As we reach the end of our journey tonight, let us pause and reflect on the path we've traveled. We began with humanity's timeless curiosity, the questions whispered under ancient skies, the wonder that has always lived in us as we looked up and asked, where did it all begin? We followed that curiosity into the story of the Big Bang, the great unfolding that set everything into motion, a cosmic moment when space and time themselves were born. We drifted into the possibility of what came before that first instant, a place where our science meets the edges of imagination, where time itself may not have existed, and where quantum fluctuations may have danced in silence, sowing the seeds of reality. We felt the breath of inflation, that unimaginable expansion in the universe's earliest heartbeat, when everything rushed outward faster than light, shaping the canvas on which galaxies would one day be painted. We wandered through the first fires, the birth of stars, the gathering of galaxies, the transformation of chaos into luminous order. Each new light a reminder that creation did not end in the beginning, it continues still, with stars being born in now. We allowed our thoughts to stretch into alternative visions, from cyclic universes that live and die in endless rhythms, to vast multiverses where countless realities may exist, each one different yet connected by the thread of possibility. And, finally, we arrived at the great and ongoing mystery, the recognition that no matter how far we reach, the universe will always hold more questions than answers, more horizons than we can see, more wonder than we can measure. This mystery is not something to be solved and set aside, but something to live with, something to cradle gently in our thoughts, like a star carried inside the mind. Together, these keynotes remind us that the universe is not only vast in distance and time, but vast in meaning. It is a place where knowledge and imagination meet, where science and wonder weave together, where every discovery opens the door to more mystery, not less. And in that endless unfolding, there is something profoundly comforting, that our curiosity will never run dry, that the story of existence will never be finished, and that in every moment, we are part of something far larger than ourselves. As you rest now, you carry with you not just facts about beginnings and theories of origins, but the gentle reminder that you are a piece of this grand universe. You are made of the same stardust that once burned in the hearts of ancient suns, part of the same mystery that stretches beyond time. The universe began in mystery, it continues in mystery, and it invites you, always, to wonder.